Hello students, welcome back to our channel. Next important third unit compiler design topic is basis of a compiler. So for the processing of compiler, so here they have divided into two bases. First one is analysis, another one is synthesis. Analysis can be divided into three types, that is lexical analyzer, syntax analyzer, semantic analyzer, and synthesis base can be divided into remaining three types. Okay, first is lexical analysis. Lexical analysis is also called as scanning. So in this base, if you are giving any source code, that source code can be divided into small parts, small pieces of code. That pieces of code is called tokens. Okay, second base is syntax analysis. Syntax analysis is also called a parsing. In this base, after generating of tokens, it can be converted into the hierarchical structure that is called a parse tree. Okay, third is semantic analysis. In this semantic analysis, they have to check whether this code is correct or not. That only will cut down. And next is, that is a synthesis base, intermediate code generation. So intermediate code generation, they have to generate intermediated code. Okay, so they can easily translate it to the machine code. Next is optimization. So in this optimization, they have to reduce the intermediate code size and reduce our code memories. Okay, and next basis code generation. For the final, it will generate machine code. So the machine code can be easily understood by our system. So first we have given input source code that can be converted to the final target machine code. So it is the basis of the compiler, you have to understand. And additionally, they are having simple table. So for the simple table, it has to store the values of the variables. Okay, in input you are giving some variables now, so that variables values can be stored in the simple table. Okay, and finally they are having some additional error detection and recovery. Error detection and recovery means each base they have to check whether it is having error or not. If it is having error means they have to detect. And I will give one example program. First, it will has a is equal to b plus c star 60. So it is my input that can be given to the lexical analyzer. So lexical analyzer can be converted the variable into tokens. So the tokens can be represented as an identifier. So a is represented as a ID1, identifier 1. B is represented as a identifier 2. Like this it will come. So after conversion of tokens, it will give to the syntax analyzer. So syntax analyzer convert that tokens into the parse tree. So parse tree, how you have to draw? We have to draw from left side to onwards. Okay, so it will draw like ID1 equal to, so remaining it will have ID2 plus ID3. So it has additional multiplied with the 60. So that is having syntax analyzer. Next is we have to given with the semantic analyzer. For the semantic analyzer, they have to check whether it is correct or not. If it is having any database or like I want to convert one data type to another one data type, it will convert like this. Here I am having 60 means, so I want to convert into to float. Into to float of 60 means it will convert like this. And another one is next basis intermediate code generation. So the intermediate code generation starting from the bottom side right side onwards. Okay, so bottom side right side onwards, it will shows like first it is int left right side int to float of 60 can be stored into one instruction, that is T1. Then now it is called int to float of 60 is called a T1. Then that T1 can be multiplied with the ID2. So that is can be stored in another one variable that is called a T2. Then now it is called a T2. Then what will become? ID2 can be added with the T2. So that can be stored to another one variable that is called a T3. So it can be stored in the ID1. So this is the intermediate code generation. And next is optimization. For the optimization, you no need to put like int to float, you have to convert that value. So 60.0 it will be converted. Okay, so 60.0 can be multiplied with the id2, that can be stored to t1. So directly you have to add with the id2. So id2 plus t1, it's stored to the id1. So this is the optimized. For the intermediate code generation, we are having 4 lines of code. For the optimization, it has only 2 lines of instruction. Okay, finally it has stored with the code generation. So code generation, it has to generate machine code. So what is the machine code? Here we are having what are the identifier we are having. We have to store in one register. So first it will started from id3. So id3 move to one register. So I am using move that register id3 can be moved to the r2 register. If it is use the r1 also, you have to use, no issues. And that register value can be multiplied with the 60.0. 60.0 is a constant number, so you have to mention with the hash. Next, so the 60.0 multiplied value that can be stored to the r2. So normally the storing of register can be started from left side to right side. So what the process will done now? So that product will be stored in the right side register value. Okay, so after that it has multiplied with the r2. So r2 can be stored with the 60 and r2 multiplied value. Then you have to move with id2 with another one register, because we already done with id3. So then you have to do with the id2 with another one register. Then now r1 having id2 value. Then next you need to add r2 with the r1. So now it is the addition value can be available with the r1 register. Okay, then you have to move, because we need to display id1 only. So you have to move r1 with the id1. So finally it will shows id1 the value. So this is the basis of the compiler process. First we have to give an high level language that can be meet to each and every basis of the compiler. Finally it will produce machine code. Okay, I hope students you all are understand. We will see in the next video. Thank you. Bye.